here. Hello. See if he's stuck. He might be stuck muted. Do I might need to unmute him. Hold on. I think I trapped him in the endless circle of muteness. Hold on. There you go. Did it pop up for you?
All right, I think that
there
got it.
There we go. We got it. How are you today?
Hi, I'm great. Thanks. You?
We're doing good. We have both of the classes for GATE today on. So you have the 3rd through the 6th grade. You've got all of us on. So there is like 19 of us all on at the same time.
Excellent.
And
Hello.
your 2 nieces, because they were very excited to get to see you today.
Hi, Lucy. Hi, Mary.
Hi. Can you hear Mary over here? She's on my end.
I can, yeah.
Well, we were wondering if you could talk to us a little bit about what you do for your job as a software engineer.
Yeah, absolutely. Right now, my name's Tyler Vrooman. Right now, I'm a software director at Oracle in Seattle, Washington. I was a software engineer many years ago before I moved into management. I initially worked at Garmin in Kansas City for about 11 years before coming to Seattle and working for Amazon initially. If any of you have ever heard of the Amazon Go store, where I don't think there are any in the Midwest, but basically is a store where you can walk in and just pick stuff up and then walk out. You don't use a checkout or anything like that. So we built a bunch of cameras everywhere and a lot of different sensors to be able to track movements and pick up products and add them to a virtual shopping cart. And then you just walk out. It was supposed to reduce the most frustrating part with your shopping experience, which is checkout, waiting in line. So it's a pretty cool project. I can talk more if people want to ask questions on that specifically, but I'll keep going just about my background and some of the things that led me into engineering and what engineering kind of is. Is that okay?
That sounds absolutely great.
Okay, perfect. So my degree from college is in computer engineering, is the field I chose with a minor in computer science. I got it at University of Missouri-Rolla, which is now called Missouri University of Science and Technology. My job right now as a manager, I used to write a lot of software, write a lot of code, but as a manager, it's more about enabling other people and doing software code reviews and looking at other people's software and making sure it's good, it meets the needs of the organization. And right now my company, Oracle, has about 5 or 6 years ago, moved into the cloud development business. And so we just build a bunch of servers, network them together, enable our customers to run various software applications on them. Engineering in general is just about problem solving. That's the number one thing that everyone takes away from an engineering degree. So you learn expertise in various fields that you might go into if you go into let's say mechanical engineering or electrical engineering, or like I did, computer engineering. But it all ultimately boils down to problem solving. A lot of engineers don't end up working in the field that they chose for their college degree. So that's why the problem solving aspect is universal across all disciplines. I was lucky enough that the field I chose, there were a ton of jobs and still are a ton of jobs in computer science, computer engineering, electrical engineering. So that was awesome. How I got into engineering is kind of funny. When I was in 3rd grade, I loved trains. I watched movies on trains over and over and over. It wasn't until about middle school that I realized being an engineer wasn't driving a train. but yeah, that was a fun realization. I I got into it in high school. I think high school. There was a program at University of Missouri Rolla called the Jackling Institute. I don't know if anyone's familiar with that. It was pretty obscure at the time, but it basically showed you a list of engineering disciplines and gave you a summary of each of them from representatives from each of the disciplines that Rolla had. It was really cool. It made me continue to want to go into this field. I mean, I was already interested in math and science, and engineering as sort of a natural progression if you have a real strong interest in those areas. They also ended up with there's a research program that the Jackling Institute also did, where you could do a few months of, or a few weeks, sorry, of kind of intense research into one of those fields. I ended up with ceramic engineering as the one that I did, which I learned I did not want to do. And I don't know if anyone has ever even heard of ceramic engineering. It's one of the more obscure disciplines, but if you think about like the tiles on the space shuttle, they're created by ceramic engineers to be able to withstand intense heat on the outside of them. But the underside of them that's protecting the inside of the space shuttle stays really cool. It's pretty fascinating. They actually showed me one of the tiles that you could put at 2000 degrees Celsius, which is crazy hot. And within about 30 seconds of taking one of these tiles that's about like that big out of the oven, it's still red hot in the middle, but you could hold it from the outside of it because it dissipated heat so well. So it's a neat area, but it wasn't for me. I found computers were more my thing, and I got into that more in high school with a computer class that had just gotten started, learning about how to repair computers. It was more of a tech support type thing, but it made me just feel comfortable working with electronics, networking the school, so connecting all the computers together. This was all before Wi-Fi, or right around the time Wi-Fi was becoming a standard, but none of the computers in the school had Wi-Fi at the time. So that got me really into computers. So I ended up going to college at University of Missouri Rolla, majoring in computer engineering, where I took various programming classes, various electrical engineering classes, lots of problem solving classes. So you take lots of math, lots of physics, and really computer engineering is just a mishmash of computer science and electrical engineering. So computer science is really solving problems through algorithms. So through computer programs that you write, through functions you write to solve particular problems. Whereas electrical engineering is building the electronics that computers or various things, like even your toaster sometimes has a processor in it. And an electrical engineer would have designed the circuit board that goes in. I should have actually brought one of my taken apart products to show you what a circuit board looks like. But the electrical engineers build that hardware, connect it all together internally, and then the computer engineers, or the computer scientists, they write the software that enables it and makes it all work. So little show and tell. Here's a really old product. This was actually the first thing I worked on. It's a keyboard for the Cessna Mustang jet. So this enables the pilot to enter. I don't know if you can see much about it. Make it a little bit easier to type in airport codes or coordinates, and control the display on the jet. So what this product has is various LEDs that light up behind each key, so you can see it at night. The key presses, the knobs on it, has the joystick. So all of that, I had to write software to, one, get it to boot up. So you kind of take for granted with your computer or with your tablet that there's a lot of software that goes into just initializing everything. So making the processor actually run code that you've written. And then it has communication it has to do with something else. So if you think about with your tablet, It's talking to various application servers. So every app you run is either going to be self-enclosed in that tablet, or it's talking to a server somewhere where you're communicating with other people. So there's a protocol, there's a communication language essentially that that has to be written, that both of them speak the same thing. And so we had to do that with this controller, where throughout the jet, this controller connected to displays, connected to other parts of the jet to allow it to talk to it. So that was my first project. It was out of college. It was pretty cool. It was fun. I did the manufacturing on that product as well. So if you think about when you're building something, if it's not just strictly software, you actually have to assemble it somewhere. And so Garmin had a lot of their avionics were all manufactured in Kansas City. So I wrote a lot of test software for it to make sure that quality control was good, make sure someone didn't screw something up, an LED wasn't accidentally misconnected or not connected, things along those lines. And it gets a lot more intense as you ramp up volume. Like there were, I don't know, maybe 100 of these jets built a year. But when you build something like an iPad, for instance, that are manufacturing 40 million of them a year, there's a lot of engineering work that goes into just assembling that and doing it efficiently and quickly. Let's see. I don't know. That's probably just in terms of background, in terms of what I've done at some of the jobs. Sorry, I keep getting notifications. In terms of at least one of the jobs, I can show some pictures too, share some pictures of some of the other products and some of the manufacturing lines, and talk about that a little bit, or we can go into questions. What do you think?
Well, as you have been talking, I've got a little list of questions, if you're okay with starting with those.
Absolutely.
And then if anything you want to elaborate on those, I'm sure the kids would be more than happy to hear.
Sure.
So one of our friends asked, like, how did Amazon Go make sure that no one stole the product, since there didn't seem to be a cashier in there?
Good question. We did a lot of testing initially, and like I even brought my my middle daughter, was about 18 months, I think, at one point, where you'd have a kid who the cameras were used to seeing adults, and there are cameras all across the ceiling of this place, in the shelves, sensors everywhere. There were actually cameras that were very similar to, if anyone's ever used the Kinect, the Xbox Kinect, that tracks your movements. It's very similar to that, where there are various technologies you can use to track movement of objects. And so we did testing, and I brought my daughter Willa in to test as a little kid who would just knock all of the food off the shelves and make sure that the software could handle those cases, and a kid who's 2 feet tall instead of an adult that's 5 or 6 feet tall. We did fraud days, is what we called it. And so they were test days where we would bring people in, and people would come in. I don't know if you've seen it at like a marathon. They sometimes give out these reflective jackets and like towels you put around you. So people would put that over their head and walk in, or come in with an umbrella and change shirts under the umbrella and then take the umbrella out because the cameras were all above. So we did all of these things to try to make sure that that people, our false detection was as low as possible. But ultimately, what we worked out was, it's better to give something away for free if we don't know the answer. And so with computer vision that uses machine learning to be able to detect objects and detect motions and gestures you're doing, like your arm going into the shelf like that, there's a confidence score that it ultimately generates. And so based on that and other data, and a little bit on your habits as a customer historically, are you more likely to be fraudulent than someone else? Do you return thousands of dollars of merchandise? There are all kinds of things that go into it to try to reduce that, but it's possible, and it's possible that we get it wrong sometimes. But it was actually a really low amount from our real data that we would actually get it wrong. So it was interesting, but that's definitely something that you don't really think about when you're building it. You just want to build it.
Yeah, you're just like,
But
I want to
people,
get it done. Like,
yeah, people take
make this
advantage,
work.
and we knew people would take advantage of it. But it actually feels like you're stealing something when you try it out the first time. They
Yeah.
like to say it's a magical experience. So if you're ever in Seattle or Chicago or LA or San Francisco or New York, I think, or they're spreading out a bunch of other places. It's a fun experience.
Yeah, I had somebody ask, like, how did they have to scan the product and put it into like a cart? Or like, how did they
No.
actually make sure they got their items and like made sure you got out with what you were supposed to have?
Yeah, so you have your account is tied to your body basically, and
Okay.
so initially you scan a little barcode from your phone that's tied to your account, and they say this is your body. As you walk around, it knows it's tied to your account. They've recently done something, and this was post my time, but just it scans your handprint,
Oh, that's
which
cool.
is a little scary, but
Terrifying. Very cool at the
yeah,
same time.
yeah,
Scary
yeah. So it's
technologies.
it goes into a virtual cart. And so you can check it on your app, and you pick something up, it pops into your cart, you put it back, it takes it off your cart. Sometimes it takes a little bit of time to register, just depending on how much processing has to be done. But yeah, it was an interesting project. It was a mix of software on things like this, embedded
Yeah.
platforms, but it was also it's what's called a hybrid kind of hybrid compute model where you have some processing power on these things. It was using basically a tablet processor, and then a lot more of the intense processing done in the cloud on servers, hundreds or thousands of servers that are computing all this data, and then they all come together to figure out what the person actually purchased.
Yeah. And so Lucy actually asked, so how did the cameras report the fraud? Did the cameras actually end up reporting it, or how did they get a flag as far as something being fraudulent?
Yeah, so the cameras and various other sensors, there were probably 6 or so sensors total that were used throughout, because even the gates that let you in, there were sensors associated with those. So the cameras would just send off their data, and they were just spewing out data to these cloud servers. The amount of bandwidth, which is just the amount of data that's transferred, was immense. It was so big. At one time, we used, I think, a quarter of the entire Amazon corporate campus's bandwidth to
That's a
support
lot,
this. Yeah, I have so
especially
many
for Amazon.
cameras. Yeah, it was pretty crazy. So there were all these cameras sending all their data, and the cloud software was ingesting all this data, computing where the person was, what they were picking up, engaging with other Amazon systems because pricing was changing over time. The fraud detection code was working in the background. So all that stuff was happening on these cloud servers and various applications. So the cameras, they were smart, but they were mostly dumb, just sending off their data. And so we just had to make it as low power as possible, as compressed to data streams as possible, just to not waste compute power and waste data power, and storage as well, because for a brief period of time things were stored. So it was a lot of different software. There were thousands of people working on that project over the course of the few years that I worked on it.
Yeah, so Christopher and Ben are over there. They're sharing a computer screen. Ben's computer wasn't working right today. So like, how do the different sensors sense different things? So like, do different ones do different things?
So they were typically built with different pieces of hardware. So as this one, it has, if you can see the little gap right there at the top, that's what's called a photocell. And so it registers a signal depending on how much light is on it. So if you think with your iPad, if you cover up right around the camera, your display will go dimmer because they assume you're in the dark. That's what this does too. And so that has that sensor on it. These cameras, we would create one particular product that would just have a camera in it. We'd create another product that just had, let's say, a scale on it. Another one that had a ton of cameras on it, but maybe way lower resolution cameras. And all of them were networked together and were able to send their data off to these cloud servers to various applications for it to be bulk processed. So it was kind of, when you think of an embedded product, it's typically a special use product. Like a tablet or a phone, they're computers, they're general purpose things. They do a lot of different things. When you're building a purpose-built product, you're building a little embedded product, you're doing it to solve a couple of constraints, things like power consumption, because if we use too much power, we would melt chocolate on a shelf because we had these really powerful, right? When your iPad gets hot, if you have chocolate on it, especially chocolate that doesn't have any preservatives, which the store sold, it would melt and you'd ruin it. And so there are all these constraints that we had to work around. So yeah, that's.
I like that. That was a very good answer for that one. Okay, so one of my kiddos asked, did you move to Washington because of your job?
I did, yeah. So I have been in Seattle, or sorry, in Kansas City, working for about 11 years. I was born in Liberty and moved to a small town in central Missouri when I was just before starting kindergarten. Was in Kansas City about 11 years. My wife and I decided that we wanted to try something different. And she had lived in the Midwest for most of her life as well. And Amazon called me one day and I wasn't looking for a job. They couldn't tell me what I was doing. So it was a super secret project because no one knew they were building this Amazon Go store. So I interviewed with them and it's like, yeah, I'll try something different. Being on the coast will be neat for a little while. We honestly didn't think we'd stay here this long, but it's been great. I mean, aside from not getting to see family as much, and especially now, it's pretty tough. But yeah, it's I don't know, it's been an experience. So I was with Amazon for about 2.5 years. Have been with Oracle almost 4 years now. It's been fun. Lots of opportunities here. That's the other thing is Seattle is a pretty hot tech bed. Tons of companies here doing really exciting things. Kansas City was a lot harder in my space, at least, which was more this hardware, software development. Garmin was the big company. There's Cerner that does a little bit of that. But most of the other companies are pretty small. So just the opportunities here are pretty immense.
Yeah, a lot of difference in that. Just finding the place where there seems to be more technology going on gives you more opportunities for some of those bigger projects. So the kids are asking, like, what kind of projects are you currently working on, or like what kind of products do you build?
Yeah.
Currently.
Yeah. So Oracle's cloud. So all a cloud is a bunch of computers that are all connected together with some software that lets people run applications on them. So if you think you have, let's say, Microsoft Word, you're running it on your tablet, you're running it on your laptop. Well, you can also run it on another machine somewhere else. And that's all the cloud is running some application somewhere else on someone else's computer. To distill it too much. My products right now, I started out with a team in Oracle that did what's called virtual networking, or software-defined networking is another way to put it. And so what that is you have one computer and you have a lot of customers running applications on it, and all of them want their data to be totally separate. And so you create what's called an abstraction layer on top of the network to where I can break up every customer. So I have this physical cable plugged into my computer that all the data runs in and out of the computer with. So think of just downloading files, uploading files, things like that, uploading a picture. And so if I have 50 people all running on this one computer, and I give each of them one processor core to run on each, I also need to break up their networking. And so how their data is transferred in and out and make it secure between them. And so what Oracle did was you build another network card that essentially says everyone's traffic is different. And I'm gonna break it all up. Customer 1 is here, customer 2 is here, customer 3 is here. And in software, I can manipulate that any way I want. I can make it look like they're running a network that looks exactly like their network in their office building, but it's actually in my cloud data center. And so that's the software that I worked on initially. what I've been working on the past 2 years is a security product for Oracle that makes it to where when one customer, so Oracle sells what are called virtual machines, which are you get just one processor or a few processors, and you have multiple customers sharing a physical computer, or a bare metal machine, which means you get the entire computer to yourself. We're not running any software on that computer. Well, with the bare metal computer, there's the risk that from customer one to customer two, that maybe it didn't get totally cleaned up and it's not in a pristine state that's ready for customer two. And so what I build now is a hardware and software product that ensures from customer to customer, the computer looks exactly like it should. No customer could ever have any influence on the next customer. Which is a really important thing, because if you're, let's say, Coke, and you have your secret recipe running on a computer and then Pepsi gets it next, you don't want them to have that information, right? So that's one of the things that I've been doing. And so you want it to be really fast, because every second that we're cleaning up that computer is a second we can't sell the computer and sell the time on that computer. And so it eats into our profits and our revenue and whatnot. So it's a balancing act between security, which is always paramount, and just speed, because that results in cost.
So Ben, does that answer your question? Did anybody else? Okay, I knew Christopher and Ben asked that question. They asked me about, are you also into security, which sounds like whatever you're doing is also part of security. Make sure that the one person's not getting somebody else's data. That's really helpful.
Absolutely.
I don't want my personal secrets going out to the world. Not that they're super exciting, but you'd still want your personal files to remain personal. So yeah. I have one friend who's asking, could you have engineering involved with like writing or the arts or music? Is there ways that you know of engineering companies or engineering jobs that involve the arts?
Absolutely. If you think about electronics you're building for mixers, for instance. I mean, I worked on an audio panel product at Garmin that basically all it did was mix a bunch of audio streams, and you could amplify some of them, and you could create three-dimensional sound to where if you're looking at a radar and you have a plane coming up behind you, the audio in your ear sounds like it's moving around you. And so you can spatially change that with various processing you can do. But in the music industry, for instance, there are also mixers, there are amplifiers, there are smart microphones you can create. In terms of art, I mean, how I think about that, there are actually algorithms now that are creating art and being compared against art from actual artists for originality and making sure it doesn't look like it was manufactured, for instance. So there are various ways you could mix in things like that. You could build an application that would do that, or improve on an existing one. So there are lots of ways, I think. I mean, I'm not an artsy person at all. I have lots of artsy people in my family, but lots of musicians. It's not my thing. So I'm sure someone else could give you a better answer than that.
Hey, but I thought it was pretty good. You can find that you can use the engineering process in just about everything involved in life. You can use it to solve a fight with your sibling. If you really wanted to go through the process, you could make it happen. So
yeah,
that's awesome. So somebody had asked, how long does it take to earn a degree in, say, software engineering or a different engineering field?
Yeah, if you get so I only have a bachelor's degree. So it took me 4.5 years, but that's mostly because I didn't want to work very hard my last year. So I expanded out into another one. I wasn't excited to jump into the field and be working the rest of my life. But it's really about credit hours, just like almost any degree. So I knew people who in 3 years had their degree, and some of them came with college credit already. I went to a small school that didn't have any college credit, so passed out of some classes. You can just take tests to get credit. I think in high school, I took a college trigonometry class to get a little bit of credit. But yeah, it's typically 3 years is really on the low side. So typically engineering schools, because they require more credit hours, a lot of times 120 to 130 credit hours in college, take people 4 to 5 years is the norm.
Sounds perfect. So I've got, hold on, I'm like digging through the questions because they're sending me questions and you can't see them. Like, hold on, I gotta find the next one. Okay, so roughly how long do you work on each product that you're building? Like, they're wondering, is it like you work on it for 6 months or is it variable? Like, what are you thinking about how long it takes to put together a project?
Yeah, it's highly variable. So if you're working on solely software, so no real hardware involved, or your application is running on one of these cloud servers, so you're basically, you don't have to think about the hardware. You write it in some language that that just runs on every piece of hardware you put it on. Those projects, I mean, they could be a few weeks to a few years. I've worked on some where we took an application that was built by a previous team, and it was kind of rush built, and not a lot of thought was gone into the went into the future of it and how it might grow, like its use cases might grow. So more customers are doing this thing or that thing. And we rebuilt it, and it's called usually re-architecting it. Took us about 1.5 years with a team of 20 people. So that was a pretty long one. But when I'm building a piece of hardware and I have to write the software also, I have a project that will probably span about 3 years, trying to figure out all of the security requirements up front. How do I make sure this is the most secure thing? It solves problems A, B, and C. It's really fast. I build it to work. And then there's a lot of application software that goes on top of it. Because even the product that I work on right now, even though it is kind of like this, it's just a little self-contained piece of hardware. There's a cloud application that has to talk to it over the network to tell it to do various things. And so there are applications engineers working on that. And then it just keeps going up and up and up, the different teams that are involved with each piece of it. So when I look at the part that I do, it's just a small part of the overall project. So there could be 50 people, 100 people or more working on just various aspects that are coordinating with this product.
Yeah, so when you're working on these projects, you're not necessarily working alone. So there is a large amount of like collaboration that's involved, and you have to work as a team and be able to compromise with people, because I know that's something that's kind of hard sometimes for some of our gifted friends. We've all got very strong opinions and we like to be right. Who in here likes to be right? Yeah, all my kids are like raising their hand. They're like, I like to be right. So it's hard sometimes for us to let that go. So what is something that you've learned over the years that helps you to kind of understand or release some of that responsibility that you have to do it yourself?
Yeah, it's kind of it's an outdated thought that engineers, there's this person who's super smart, who's in a closet, and he's just in this small room that he's doing everything and he writes everything. And when you look on the movies and you see this hacker that you see all these things like the Matrix going up the screen, that's not the real world. Nope. There's a lot of talking with other people to make sure that your application is going to work with theirs. Make sure you're solving the right problem. Because a lot of times as an engineer, as I said, we solve problems. And so sometimes someone dives in and they provide a solution and you lose sight of what problem were you trying to solve. So always going back to that and saying, okay, what problem are we trying to solve? And make sure we're all aligned there. Really taking the emotion out of it. I can empathize with the wanting to be right. Lucy and Mary, your aunt will tell you that over and over.
Mary's got a smile on her face.
Yeah, it's a hard thing to break. And Amazon actually has a leadership principle that says be right a lot. Which makes it kind of worse. But yeah, but really, if you take the emotion out of it, I'm emotionally tied to my opinion, and you really just get down to, okay, so whose solution is solving the problem the best given the constraints you have? And so we do that typically with bigger projects through what's called a design review process. And somebody will do a really deep analysis of what's the problem we're trying to solve? How am I proposing to solve it? How am I going to test it? How am I going to make sure I maintain it once it's actually out there and being used by customers? And then we talk to all of our stakeholders, every other team that we're working with on this and our internal team, and we debate is this the right solution? Is there another solution? Maybe there's a better technical solution, but it takes 10 times as long and our company will be out of business by the time we would implement that. And that was actually one of the biggest concerns initially with Oracle's cloud and even my Amazon Go project is if you keep delaying the release of something, the company might stop investing and you're out of a job or you have to find another team to work on. So there are all these constraints and all these trade-offs that you have to consider. It's not always about who has the most technically right solution. That's a lot of times not the right solution to implement because maybe the technical merits of one, I mean, I have a work debate. I can also empathize with the peers, and I have a work debate with a particular individual who wants to overcomplicate everything. And we'd never release a product if we overcomplicated it the way, and we took some shortcuts that ended up working out fine with what problem we were trying to solve and how we were trying to speed something up, for instance. But this person wants to write 50-page documents that spell out everything that happens. We're like, no, we could just build it.
Do it. And sometimes you realize that with the problem, you can spend months and months and months and months planning and you go to build it and it didn't make any sense anyway, and you're back at square one in the first place. So
Exactly
sometimes
right.
these guys they like to skip the planning phase. These the ones in here like to skip the planning phase. They don't like to draw and plan. They just want to get their hands dirty with it. And sometimes that works out and sometimes it doesn't, right guys?
That's very true. If you can quickly iterate on something and see if it's going to work, and that will inform you. And sometimes when you're creating a design, you say, well, let me try out one possible method really quickly and just see what happens. And with user experience design, that's a big thing that's done, is you draw up just sketches, sometimes in crayon, that look terrible, but you say, this is how I think the flow of the user experience should be, and does that seem right? And so there's a bit of a mix of just diving right in and trying to really think about the problem and think about how you might solve it and what the next steps down the road are.
So I have a question from Kate, and Kate says, how long have you been engineering and how has it affected your mindset?
Oh, so I graduated college in 2003, long time ago. So I guess I'm at 17 years. So come December, it'll be 17 years. That's a long time.
Feels like a long time, right? But you have to say it out loud.
Yeah,
like, oh,
it does. I guess my mindset. So when I started out, through college, I learned kind of that I'm by myself on college projects, on high school projects. Mm-hmm. We didn't typically do things with larger teams. It was all about what's your contribution. Listen, there were a couple of group projects, but that's probably the biggest thing, is just you can accomplish so much more with a group than you can by yourself. And so if you try to do everything yourself, you're going to take away responsibility and ownership from other people, but you're also going to only get part of the solution typically. So working together with teams, you can be a whole lot more effective. And that's ultimately why I ended up going into a leadership path, is because I realized I could do more. I could have more influence and more system level kind of scope in terms of how the project was going, how multiple projects were going, if I was helping empower other people to be their best on the projects versus just doing everything myself.
Yeah, and I think that's the hardest part, is like we all just want to get in there and do it because my way or the highway. And I think even my kids worked on that today because we went outside and did some shelter building. So could we hold up the shelter by ourselves while we were trying to tie down and nail in the stakes? No. My kids are like, absolutely not, because like it kept falling over and it was a whole big mess until they all realized that if I held this and you took this and you got this piece, and they started working as a team and they ended up managing to do that. But It's amazing how many different things in our world require so much more collaboration. And if you can collaborate, how much faster you can get a product than saying, oh, I could do that myself. Might take you a week
It's
by
true.
yourself, might take you 2 days with a team of 5. So
Yeah.
it gets to be really entertaining and really fun. Do you guys have any other questions as far as I'm letting people come through the chat because I'm kind of seeing what comes in? Oh, they asked, what is your favorite thing that you've worked on? Favorite project?
Let's see. So while I was at Garmin, I worked on avionics first, so electronics for airplanes. And then I moved to what were called personal navigation devices. Sorry?
The watches?
Oh, no. So I do have one of those watches.
I was saying, I thought I saw a watch on.
Yeah, I did a lot of testing for the Garmin watches and some of their ads for it, but I never actually worked on them. Some of my code got into them, but yeah, the personal navigation devices were GPSs for your car. So just like in the dash, you have one a lot of times, but think about like Google Maps or Apple Maps on your phone or your tablet. But it was a purpose-built device that just did navigation. And so I worked on Bluetooth for it, enabling Bluetooth, enabling the processor to boot, enabling various displays to show images, the manufacturing of it. So the first one of those I worked on, it was the Nuvi product line that most of you probably don't know anything about because Google Maps and the iPhone kind of destroyed the personal navigation industry. Yeah, when I was building them, they made 16 million or so of them a year at Garmin, and now it's a million maybe. But that product was just really cool. I thought I got to work on a lot of different technologies and own a ton of the product, and it sold 1 million a year. And I was one of 3 people that worked on the software for it. So it was a really small team, and we all did a ton for it, but it was so fun, so rewarding. So that's my favorite.
All right, so one of my kiddos asked, what's mechanical engineering? So we kind of heard about software engineering and some electrical engineering, but what's mechanical?
Yeah, mechanical. So the outer case of this and making sure it fits into, so this fits into a dash. And so there must have been a little lip there, and there's a little connector here. So that's one aspect. A mechanical engineer would have done all that work. Make sure all the tolerances are right. Make sure the circuit board inside this all fits perfectly with the case around it, and it's all screwed down right. And you make sure that there aren't going to be issues with shorting any electrical components out. The manufacturing process is sustainable and is capable of being automated or whatnot. I have a buddy from college who ran cross country with me, who's a mechanical engineer at Boeing, and he works on the F-15 jet. And just the mechanical engineering around various parts of the fuselage of the F-15 jet, making sure that as they change components out, you can tweak designs and things like that to make sure that the enclosure is good, make sure that the materials they're using are sound. That's one aspect of mechanical engineering. There are a lot more that I'm not super well versed on. But in any project, if you think about like an iPad, there's a mechanical engineer working on the enclosure. There's an industrial engineer or a user experience engineer working on what does it kind of look like, and then the mechanical makes sure they can build it to that. Electrical engineers working on the electronics in it. There are manufacturing engineers making sure you can build it. Software engineers making sure that that the software works well on it, and that like you don't have issues like my iPhone, that when I'm wirelessly charging it, it just shuts down because it gets too hot without warning me. So, but yeah, there's so many different fields of engineering that are in everyday life that you have to think about. There's civil engineers that work on traffic patterns and building roads and building bridges. There are dozens of engineering fields. Petroleum engineers that are working on how to mine oil, natural gas, things like that, and software engineers in that area too. Like a big part of our cloud usage is companies exploring gas pockets, and it's huge amounts of data processing to model where the gas might be or where the oil might be to where they can drill in the right place. So it's a field that that you can get to almost anything with.
We like that. Okay, so Christopher and Ben, I'm not sure which one asked it because they're sharing. They're asking, do you know anything related to the building of the Sentinel-6 Michael Freelick satellites?
I do not.
We were wondering about the ceramics involved in it, but I didn't know if you had any background knowledge on that.
Do not. No, none. Sorry.
No, that one, I was like, that was a very specific question. I was
It
like, I don't
was,
know
yeah.
if I would have an answer to that. So does it matter what kind of engineer you are as far as how you get paid? Or like there's certain ones that make more money than others?
Averages, yes, there are. And there's data out there that talks about it. But it's typically, you look at it in terms of the averages across an industry, and it's all just like any job. It's depending on where you live. Like in Seattle, houses are really expensive. So they pay more here than they do in Kansas City, where houses are less. And there's more talent here. And so they have to pay more because there's more competition. But with general fields, it's, I don't know, I don't want to put any engineering fields down, but there are definitely ones that pay way less. And it's typically because it's a supply and demand problem. Like stuff in the fields of computers is really hot right now because there's a lot of demand and not that much supply. In the field of, let's say, civil engineering, there's a lot of supply and not as much demand. And so they'll historically make less, but that doesn't mean, just like any field you go into, if you find a niche for yourself, a really place where you're the expert, you can always make more just being that expert. But you have to be careful to not be an expert in a field that ends up being deprecated just because technology evolves. Or let's say you were a petroleum engineer and they outlawed all gas exploration. That would be, but yeah, but as I said before, engineering, you learn to be a problem solver. So there are engineers who got electrical engineering degrees who became consultants for, I don't know, businesses expanding their warehouses. Has nothing to do with electrical engineering, but just the learning how to solve problems. And that's why learning just one way to solve a problem, how you'll go through engineering school, that's so critical and probably the hardest thing about engineering school is they'll challenge how you solve problems and teach you. It's not about getting the right answer. It's about figuring out how can I modify, how can I create a permutation on that problem that makes it to where you can't use the tool that I taught you. You have to figure out a new tool on the fly. And sometimes that's in a test, in an exam you're doing, that you look at the question, it's like, well, they taught me all these exercises to do it this way, and now they've just flipped the problem on its head, and I have to use tricks A, B, and C to solve the problem differently. That's really what you're learning, and that applies to all aspects of life, or it can apply to.
So it's entirely a position involving growth mindset where you have to be able to flexibly think and change your ideas and be able to say, you know what, I'm learning from my failure to how I can improve for the future. So
absolutely, yeah, growth mindset is critical. And I'm glad you're teaching that. That book was amazing, almost transformational.
Did you read Carol Dweck's version of growth mindset?
Did.
Yeah, yep. See, I got you.
I'm trying to use it on my kids. It's really hard to change habits of good job for getting a good score versus good job for trying, because you always want to continue growing.
That's what we always try and talk about here. We always talk about when you've technically finished your product and you've tested it and it passed, is it ever really truly done? No, there's always something you can do to improve it again in the future. Okay, I've got one last thing from Naomi, and then we're going to let you go because we've taken up about an hour of your time, and we're super excited that you were able to join us. So Naomi says, are you weird, a geek, a nerd? She says, because if you are, I am too, and I think it's awesome, but I want you to know, and I want to see if that was ever something that popped up in your childhood to ever be called weird or a geek or one of those made fun of and bullied, picked on for being smart?
Yeah, I mean, it definitely it's unfortunate that that sometimes doing well is frowned upon, and I feel like that kind of that line of thinking is starting to change just in society in general. But I guess as a kid, I don't know. I can't remember a ton of my childhood, but I'm definitely a geek, and I was a geek, and a lot of my friends are geeks, and we do things differently. And engineers, I don't know, when you think a little bit differently, you act a little bit differently. So I mean, I played sports. I played basketball. I ran cross country and track, and so I have multiple friend groups, and they weren't always the same. But when I went to college, the really amazing thing about college is no matter what kind of your personality is, you'll always find people who match that personality, even if you didn't growing up. And so I found when I was in high school, ran cross country and track, there was never the kind of geek crowd that I was on Scholar Bowl with, and math club and all that stuff. They weren't in sports.
Yeah,
But in college, a lot of really smart people who also were really great athletes. And so we had both of those things in common. So it's the first time I kind of had both of those that overlapped. It's not everyone's experience, but I just say do what makes you happy. And one of the things that is, when I was younger, girls weren't as motivated into math or science, and I feel like a lot of STEM activities has changed that. And I've pushed my daughters. I have three girls. We do electronics projects together. We do they build magnet tiles. We do a lot of fun engineering things together, and I'm trying to get them involved in projects with me. But that's something that just wasn't even available to me growing up. But I feel like that stereotype is totally out. Like one of the best members of my engineering team right now is a girl who graduated college in August, and she's brilliant. She's super motivated, and it's awesome having her on the team. And also, if you think about different backgrounds, bring different different thought processes as well. And so having teams that are mixed up of kind of multiple backgrounds, multiple personalities, brings different perspectives to it, which help you solve problems better. You don't want everyone who's a cookie cutter image of each other. And so the highest performing teams are the ones that are most diverse. So yeah, stick with it. Be weird. It's not weird depending on which circle you're in. And definitely in college there are clubs, and in high schools and junior highs there are clubs for things that weren't around when I was a kid, but I would have loved getting into. Like I didn't do any programming until I was in college, but I had a lot of friends who went to bigger schools who did that, and they were so far ahead of me. And so that's something I'd encourage. Yeah, go with what makes you happy.
Yeah, don't be afraid to be you, I think, is the biggest message with that there. Well, we thank you so much for sharing your time with us today. I know the kids are really going to get a lot out of this. There was a lot of really good information. Can everyone give him a round of applause on your lovely little screen? Thank you so much.
Thank you.
Tyler.
Thank you. Sure.
Appreciate it. We will send you a copy of this if that's okay with you. I'll send it as a link. I went ahead and recorded for today so that others who missed might get a chance to still hear you speak. So, this one says, did you ever do anything other than sports or STEM?
I don't know. I played video games a lot.
Okay, video games are going to be healthy for you. See?
Yeah, I still watch cartoons.
Yes, cartoons. They're my favorite. All right. Well, thank you so much. And if we have other questions, is it okay if we email those to you?
Yeah, most definitely.
All right. Well, everyone
have a good weekend.
Bye, guys.
Bye, Mary. Bye, Lucy.
Thank you.
Sure.